Okay. So actually, it's a kind of, did you bring your coffee? I said.
I have my water.
Okay.
I've had so
It
much coffee.
counts, so
Cheers.
cheers.
No.
The thing is, this is something that people take for granted. They think that they know,
Mhm.
but they're like islands here
Mhm.
and there. One of the things that I need to do all the time is whenever I go anywhere, I should just organize the things. Then I can feel my brain can start working. So one of the things which is important is we do the same thing for the software, hardware, and so on. Definitely, I'm not going to waste your time to say that, hey, Kelly, what is hardware? What is software? You are the
Oh,
answer, yeah. But the thing is, this is just one classification, and I'm
Sure.
gonna just
There's so much to ID.
yeah, I'm gonna tell you some of the pitfalls of this classification, but we are going to divide software into two parts.
Okay.
System software and
Mhm.
applications. Yeah.
Okay.
I just regret why I didn't insist to talk a little bit about hardware and software. Correct me. Can we say that our body is our hardware
Sure.
and the brain is our software? Yes.
Allow it. Yes.
Our
Maybe the
brain.
spirit is the software. Either
Well,
way.
the thing is, exactly that is something that I treat with
Yeah.
students, and they say, yes, yes, yes. I want to say that, you know what?
Yeah.
Our brain is like the CPU and not the
Yeah.
hardware.
Absolutely. And that's how in my tech class, I'm like, I do exactly like the brain is a CPU. Like you want to think about the spine as the motherboard. Everything kind of plugs into the nervous system, and then the RAM is your memory, your short-term memory. The hard drive is your long-term memory. And I do like to equate someone that doesn't know to the body. Because you're right, like that's how people that don't know can really make it make sense, right? I know it's simple for us, but
Excellent. And before that, I turn into become atheist.
Yeah.
I said the spirit is the software. Then it was like, oh, what should I do? So I thought that the thoughts that we have in the brain, we can say that they are the software.
Yeah.
So now that we have a kind of understanding of those examples, if we go, what is the most important thing that we have in our brain, I mean, in our thoughts? So a software is divided into system softwares or applications. But the very first thing, if we want to say, some people say bias is the most important software. Some
Okay.
people say that, how about the operating system? Um, in your classes, how do you describe operating system to?
I would say the operating system is basically very high level. It's the software that allows you to interact with the hardware. And it also allows you to interact with the applications. It's kind of the middleman for you to use the computer, basically.
Excellent.
You install the operating system onto the hardware, and then you install applications into the operating system. And I obviously go, because I teach trade students too, and some of them are like, I'm like, okay, hit Control Alt Delete, and they're like, slow down, like, you know what I mean? But that's kind of how I try to explain it. It's what allows you to use the computer. It will give you a graphical user face and lets you actually do things. I kind of explain that everything that you can do from a graphical user standpoint, you can do in command line, like we kind of go into that. But that's how I would explain to someone that has no idea.
Bravo.
Is it good?
This is awesome. I always use this
Yes.
saying that operating system is like a manager.
Okay.
And
I'm
the
gonna steal it from
manager,
you.
yeah, and the manager is the one who first needs to, hello Pamela, this
Yeah.
is your office, so as a kind of round of handshaking,
good.
knowing so first knowing the environment,
Mhm.
and then after that, okay, Kelly, would you be kind enough to take care of this project
No.
and so on and so
Never.
that happens.
Yeah.
Yeah. So, and when you are done with that, then so Kelly, thank you very much. Go have a break. And when you're done, there's another project waiting for you. So it means that first knowing the environment, assigning the resources to
Yeah,
projects,
that's a
and
good
when the
one.
projects are done,
Mhm.
so you dedicate them to another project. So because you are watching a YouTube video, and after that's when you're done, the graphic card is going to be dedicated to a game, for example, and so on and so forth. So just a nice manager.
Yeah, that's
could be a
good.
kind of example. So, but the thing is, I know that she's amazing and very kind. But is she responsible to, for instance, schedule rooms or something? No.
He would.
You destroyed my whole
Pam
example.
would, because it's Pam, but yeah,
Yeah.
another manager wouldn't.
Yeah, yeah. But in general, even if actually Pamela is the prime example for like being equal to Windows, because Windows
You mind if
is,
sit on?
yeah, I just wanted to do that, but I was not yet. Awesome, thank you. Okay, I love this slide. I mean, that's perfect.
Even
Yeah,
though you don't have a window, like just like us, we're making the best of our little spots, you know what I mean?
exactly. So, Kelly, the thing is, Windows is like Pamela.
Yeah.
Although the primary responsibilities are just those three,
Mhm.
it goes way beyond. For instance, taking care of antiviruses.
Yeah.
It's not the responsibility of the operating system. Having filters, having all those kind of facilities, they are coming into utility parts.
Mhm.
And if you see that someone is like Pamela, they take care of them, but that's under the utilities. Like we had before, we had a Vista, we had Avast, sorry, antivirus.
Yeah.
We had Norton antivirus. What are the others? Can you
There's like-
recall?
There's
Norton,
like,
Kaspersky
mhm,
is the other one,
mhm.
and many. But well, now we don't really use them because they're heavy weighted, and we can just simply use what we can get from operating system. So now we saw that, and the other example for utilities is like a spin disk.
Mhm.
They try to increase the performance of the, right? So getting back, now we press the button,
Mhm.
Windows is up.
Yeah, okay, I picture it.
Yeah. And then antivirus is there.
Mhm.
We have everything, but when we can start communicating with computer,
Mhm.
how we communicate with each other.
Like you're asking me? Well, we speak
Yeah.
to each other, we message each other.
Excellent. So we use language.
Yeah.
Exactly. That is the part that we have everything up and running ready, but we need to communicate. So we go to the language. I'm asking you something. Let's just have something here.
Mhm.
Okay. Imagine that I have a computer. Don't laugh at my
Beautiful. No, that's good.
yeah. So I imagine that I have a computer
Mhm.
like this, and I have, there we go. And imagine that it's kind of heavy,
Mhm.
right? And I have it like that. And I ask you, here is the, sorry, here is the computer.
Mhm.
And we have a kind of human over there as well,
Okay.
which is going to be this one. So which one do you prefer to have?
Who would I prefer to speak to?
No, I'm saying that, and imagine that. So let's have a few of these things too.
Yeah.
So do you prefer to imagine that the computer is heavy as well?
Okay.
So do you prefer to put computer on the head of this poor guy, or do you want to say, hey, you are allowed to stand on top of this case, for example? Which one do you prefer?
Well, I would want it on my head.
Let's make exception
Okay.
of our team.
Okay.
So in general,
Mhm.
which one do you prefer? So to have, well, I think that your spine, your neck is way more expensive.
I think so too.
So
Yeah.
let's have human on top
Okay.
and computer down.
Okay.
Always remember that example.
Okay.
So sorry, I know that you're master of this. I just repeat the way that
I'm a student of life, and the way that other people teach as well helps me, and it helps me teach other people, and it helps me teach myself. So
oh,
don't
so far.
feel
Yeah, but the thing is, I think that we can just, I mean, for instance, I'm gonna borrow your example about the spine motherboard and so on. I never use that. So this is just a friendly communication.
Like
conversation.
there's so
Yeah.
many different ways that you can simplify the same concept
Yeah.
and whatever's gonna work for you.
Yeah, exactly. Imagine that this is how we classify languages. So the languages that are close to human level, we call them high level.
Okay,
The languages that are close to computer, call them low level.
okay,
So, and here high and low doesn't mean that something is higher quality or lower quality or
Yeah.
something like that. It's just the proximity to the language of computer or the proximity to the
Okay.
human.
gotcha.
So the first year that they had computer could understand nothing but
Ones and zeros.
exactly. So for that, they use 0, 1, 0, 1. And imagine that computers want to communicate that they say
Yeah.
that 0, 0, 1, 1, 1, 1, 0.
Oh my gosh, you're taking me back to like school.
And the other computer said 0, 0, 1, 1.
Yeah.
1, 1, 0. So that computer, yeah, we cannot understand it, but it is very good for them. So it's going to be like this fast, high performance, everything is awesome.
Yeah.
But in that level.
Good old binary.
Yeah. And the thing is, now we wanted to bring computer to the society.
Mhm.
So we just jam-packed all those things together, said that, okay, this is just print.
Yeah.
This is save. This is, but if you open it, you see that, wow, lots of 0011s and
Yeah.
so on. So they are high-level languages. And one of the first high-level languages is formula translation, or for short, Fortran.
What is it?
For formula translation or Fortran.
Okay.
So, and here we had, I'm not gonna take a time for that, but we had first saying that's awful way of. So if I have Excel. So the thing is, we had, for instance, 0, 0, 0, 0. Then what's the next number? 0, 0, 0, 1. Result 1. Okay, the next number is
0011.
0, 0, 1, 0.
Oh,
Don't
got
worry,
me.
but there's a kind of game we are gonna play to
Okay.
see what is happening and how it works. Then it's going to be 0, 0, 1, 1, and the next one is going to be 0, 1, 0, 0. And I promise just to go a little bit further. So this is going to be 0, 0, 1. And what is this one? 0, 1, 1, 0. Lovely, yeah. So 0,
Start.
1,
You know,
1,
actually, like, there's some stuff that I might have learned, but it's been so long, and I'm just doing so many other different high level things that
yeah,
it's good to get back to the basics.
yeah. If I don't teach that, I'm gonna forget.
Yeah,
So
yeah.
it's for me, it's a little
Like
bit
even like
easier.
subnetting and like creating IP addresses, I
Yeah.
have a calculator that does that for me now.
Yeah.
I learned how to do it all manually in school, and the teacher was like, "You need to learn how to do this." Like now, there's websites and subnet calculators and stuff. But yeah, it is. There's something humbling about going back to.
Yeah, the thing is, why tell to students these kind of things at the
Yeah.
beginning? Because it's gonna just tell them the layers below when they type
Yeah.
A equal to 10, so
Yeah.
it's gonna convert it to that. The thing is, what is the you remember first grade? They
Ugh.
showed us that okay, this is 1 apple, 1 orange, 2. So and then I remember we had a box of 10 pencils and then the box of 100 pencils. So the thing that they teach us was 100, 10, and 1. So for instance, if we said 300, 372, we knew that we have 2 boxes of, well, technically 2 pencils, 7 boxes of 10 pencils, and 3 boxes of 100.
It's weird how like the brain is easy to translate that, right?
Yeah.
Based on like before.
True. And then this one is nothing but saying that 10 to the power of later in the 2, 3 grades after that, it was 10 to the power of 0, which is equal to 1.
Mhm.
And let me just say if I say a or any number to the power of 0 equal to 1, the reason for that is a equal to m minus 1, right? It's equal to that.
Okay.
And then it is equal to say a to the power of m divided by a to the power of m. So it's going to make it 1. So
Yeah.
that's why the first column, which was 10 to the power of 0, which is 1, and then 10 to the power of 1 actually, and then 10 to the power of 2. But why it is important? Because technically here we have exactly the same thing. So we have some lamps here. Imagine that the first lamp is 2 to the power of 0, which is 1. The next one is 2 to the power of 1, which is 2. Next one is 2 to the power of 2, which is 4. And the next one is 2 to the power of 3, which is 8. So if you see here, all the lamps that we have here are off for this one. This one saying that 1, 1 and nothing else. This one 1, 2 and nothing else. This one is 1, 2 and 1, 1, make it 3. So in that case, we can simply have 0, 1, and look at the others. So 3, like 4, just this lamp. We can even guess how to make 5. So 1, 4, 1, 1. So it's exactly what we have it here. How about to create 6, 4, and 2? How about to create 7? All of those numbers and how to.
I'm like, this is cool. But like, I probably know this already, but yeah.
This is how is how and getting back to the things to connecting the dots.
Yeah.
So we have those languages,
Yeah.
0, 0, 1, 1, and so on. And then we group them. The other language that we had was Oct language. And after that, we had Hex language.
Yeah.
And then we had assembly language. So that was the very first, if anybody asked in any interview, guys know that the first low-level language that we used alphabets for was assembly. So, but
we've come.
Yeah, assembly was not easy to understand, high in performance. So this operating system, Microsoft Disk operating system, was built on assembly language.
Interesting.
C was built on assembly language and many others.
Yeah.
But we talked about assembly, now Fortran, BASIC, GW, QBasic, Pascal, you name it, a ton of those kind of things. But the problem of these guys are they're easy to understand, easy to debug, but very dismal in performance. So we needed something in the middle.
Okay.
So
powerful and easy to understand and troubleshoot and learn or whatever.
Exactly. So we needed something in the middle, and there was this one guy who is very famous, and why the Dennis Ritchie comes to my mind, maybe because that's the person. So
is it a big bearded man?
all
yes, the programmers. Again, like I did take a programming class like 20 years ago. Like I recognize this guy actually.
Yeah. So Dennis Ritchie, and there are some nice things about him that I'm going to. So I'm gonna tell you this. So he invented C programming in early 1970s, and another name that was Lady Lovelace, Ada Lovelace. So
that's the name,
yeah. So this is something that we have in the middle. So C and Ada. So this is another one. They created something to get the benefit of both high level and low level. So they call them middle level languages.
Okay.
And this gentleman was getting back to operating system for a sec. This gentleman was in a part of Bell company.
Okay.
Before they divided into AT&T and Bell. So he was in the lab, Bell lab, and they were planning to build an operating system for mainframes for supercomputers back then.
Well, like the whole room was the computer, pretty much. Yeah.
I was like, be one of them.
Yeah, it's wild to look at those
Yeah.
pictures now.
Yeah, and the project name was Multi-X. A ton of engineers working on that project, and he had some amazing ideas. Going to the manager saying, "Hey, I have some cool ideas.
Yeah.
Get back to your work."
And we needed a pan.
Yeah. So the problem is we didn't have pan
Mhm.
back then, so he was just depressed. Had some options, just quit.
Mhm.
What? So he just went home thinking that I'm just only person. Let's just implement it by myself. So there are multi-X, I'm gonna be uni-X. And you don't see any sign of multi-X, but you see the sign of multi-X does not exist, but Unix
Like it's
is.
running now.
So
Mhm.
isn't it interesting?
Yeah.
So Unix has come from there, and the Linux has come from Unix.
Yeah,
And
Unix is like not the kernel, but it's kind of like
the grandfather
Yeah.
of those
and
operating
like
systems.
Mac OS and all that. It's all based on Unix, right? Like
And-
I kind of know some stuff.
And then the children of them are
Yeah.
those that we use in portable devices, like
Yeah.
any version of the Linux portable Linux that we have.
Yeah.
So this we owe him a lot because of all the things that he did for us. And now we have high level, we have low level, we understood middle level. But the
Okay.
thing is, everything was peacefully, just slowly going in the dawn of computer history, while Microsoft invented Windows 95. And before that, it was a shell on top of DOS operating system. We had Windows 1, Windows 2, Windows 3, Windows 3.3. I remember I worked with them.
Mhm.
And then instead of going to Windows 4, they started stealing some ideas from Mac OS, from other awesome operating systems back then, and then we jumped to Windows 95. So everything became visual. We started having graphic user interfaces.
Mhm.
The things that we needed to write, for instance, 300 lines of code just to have kind of box you drag that drop. So we
Yeah.
had a wizard for the first that showed that, hey, you just need to click there and say that, okay, what are you going?
Yeah.
What do you want me to build for you? It's
Yeah.
like a genie out of the box,
Yeah.
out of the lamp. So those kind of things brought us to have languages that they started predicting what you want. The
Okay.
very first of them was Visual Basic, and after that we had Pascal. Pascal was high level, but we had Visual Pascal, that they called it Delphi, the god of knowledge. So this started, I mean, just progressing. And now when we look at this picture, we see here is the place that we are working. And Python is in that category. Super high level or fourth generation technology, 4GT for short. This is the category that we are talking about. Some people mix them together, saying that still we are in the era of high level. I don't have any argue with them. I can understand it is the job for them. But there's one thing and one trick question. SQL. What do you think? Is a SQL a language?
Well, I'm not sure now. I feel like it might be a trick question.
Mhm,
I mean, SQL is a
It is.
service.
mhm.
It's also an application. It's yes. Yes, well, maybe it's not a language. No, it is. I don't know.
Let's bring back the camera to the society.
Okay.
You are an architect. Do you need to know C or C# to design something by computer?
I would assume not. I would assume they're using like CAD and all kinds of visual.
Automatic computer aided design, for sure, AutoCAD, is the result of the marriage of computer engineers and architects sitting together, talking, sharing, having coffee, and finally creating one product. How about accountants and engineers? Excel. How about designers? And so we see all of those guys are not in the category of the computer languages. They
Right.
are in the category of applications. So applications are something that I'm not expert in computer, but I want to use it, that kind of thing. So in terms of working with data, I want to have a nice, neat storage
Mhm.
and work with the data. I leave it to you to consider if it is an application. So SQL structured query language, because we have language, is it really language? If it is, what is the package that, what's the output that you can get? Are you going to make a kind of game kind of things, executable thing? Because we don't have that, I feel SQL is under the category of application. Some people believe like me, some people think that they are languages because of the code that we have. But what I'm saying is it doesn't matter which one is right or which one is wrong.
Fair.
Have your signature of definition saying that these are the things that make me think SQL is in this category or in that category.
I guess like, yeah, as long as you understand enough that you can justify your reason and explain it. I never thought about that.
Getting to the next part. By saying that we are done with this,
Mhm.
and I promise not to take your precious time more than 20 minutes. Is it fine?
My actually my nephew's coming at 2:30, so I have until like 5 minutes before 2:30.
Awesome. So, perfect. The thing is, if we go to the next file here, so I think that you are the best to read this name.
Guido van Rossum.
I think that he is from your father's country.
Oh,
really? And yeah, and it was just a kind of 2 week vacation he had, and he wrote Python. I'm happy that it was just 2 weeks.
I was gonna say I've done nothing with my life. I've had a lot more than 2 weeks.
Why we like that Python? It's a kind of general purpose language.
Okay.
You can just use it for many things. Data science is one of them. You might say that how about Julia? Yes, Julia is a fast growing language in the field of Python, but we don't have that much, I mean, a strong community the way that we have it here.
Okay.
And the libraries, maybe soon. And very much easy to write, easy to interpret. When we wrote code in C programming environment, we wish we had the pleasure of just typing one line and it does all the things that needs 10 or hundreds of lines. And then huge amount of open source libraries. A difference between open source and free, you know better than me. The good thing is the support that we can get from the open sources. And if we need, we are going to just go to premium version used by many major tech companies at the moment. And well, we have 3 major environments to work with Python. One of them is text editors like Atom, IDE like PyCharm, Visual Studio Code. We can just say that plug and play, that kind of thing. And the notebook environment. Actually, notebook environments, they came to this world early 2000. And the reason for having them was just to have a nice environment that it doesn't frustrate us to go 100 lines and then say that, okay, you know what, go back to line 1, you have error there. So run, go to the next cell, go to the next cell. And it was that much of an awesome idea that apart from the initial intention that they made it for academia, now vastly they use it in all places, including SageMaker in AWS services. So Google Colab is one of those things, and Anaconda, for example. So we talked about some examples like Sublime, Atom for IDs, PyCharm, Spider, and for notebook environments, we said Jupyter Notebook, Google Colab.
That's funny, just really quick, when you were kind of writing the notebook stuff, like we didn't do that we used kind of more like Notepad++ and stuff like that. And that was like a big deal at the time that you could actually have things highlighted and you could have your brackets all together and it was easy, but like, yeah, you don't get feedback section per section and you can't move around as quickly. Like, so I was just like, wow, like, anyway, just kind of letting you know how, like, if you're not familiar with something, like you don't really appreciate what you don't have until you find something that does that thing. You know what I mean?
True. One of the problems of other environments that I work with, like Jupyter Notebook, was if you need something like, because let's put it this way, if we need to get something very simple, we go to for instance, one of those convenience stores.
Mhm.
But if you want something a little bit sophisticated, we need to go to a place like like Canadian Tire, for instance, Home Depot,
Mhm.
that has several aisles and so on. So I visualize those libraries and as those kind of aisles that we have,
Okay.
right? And whenever we import, we say imports NumPy as NP.
Mhm.
It's like go to Home Depot, go to aisle number 10.
Mhm.
Have those two boxes for yourself. So you can start just working on them.
Yeah.
We didn't have that in the time that I worked with Basic when I was a kid. I
Mhm.
just write those things. Why? Because the whole things could be fit in one convenience store.
Yeah,
It was like old fashioned kind of just
there's only so much.
stores that, yeah. And you do that. But when you have hundreds of thousands of objects,
Mhm.
you can't fit them in one store. You need
No.
to have a kind of big environment.
Yeah.
And it's like, if you have just 5 books, you don't need bookshelves.
Mhm.
If you have 100, you need that. But if you have a million books, you need to have a kind of big center for it. We are talking about something like billions of functions. We
Yeah.
need to organize them, place them into different aisles. That's
Yeah.
why they didn't want to tease us to say, okay, you have to say numpy dot and do something. It means that go to Home Depot, go to that aisle and pick the tool that you want.
Yeah.
So that is the philosophy behind all those dot, dot, dot in libraries. So getting back to the things that you said, I use that, but what about this? The problem of many places like Anaconda,
Mhm.
Jupyter Notebook, is some of the libraries are not compatible with the other libraries.
Okay.
The good thing about Colab is 95% of the things already there, installed, compatible version, they upgrade them all together.
I do love Google, even though it's an evil corporation.
Yeah.
I'm a Google person.
Me too.
Yeah.
More democratic. And the thing is, in the 5% of the cases that I needed to install something,
Mhm.
the version, I didn't receive any incompatibility kind of warning or whatever. So that is why I stuck into just
Yeah.
Colab. So that's why we use this by saying that. So this is just a joke for you.
Mhm.
How to the only thing is whenever you want to use Jupyter, I don't know if I have the Jupyter notebook. Jupyter. Yeah, I installed it there. If I just click on this thing,
Mhm.
by default, it's going to bring me to a kind of space that necessarily not my ideal place to work with. Let's say this one. It is going to open in here, and it is not the easiest way to just go to somewhere else, like change the location.
Yeah.
You know what I'm saying?
Yeah.
So if you want to use Jupyter and you don't want that kind of struggle and trouble, what can we do? So we say either, I don't know if I've defined it in the path. That's not what I go, for instance, to D, CD test. For instance, I want to open Jupyter there. I say Jupyter Notebook and sorry, Jupyter is not working. Okay. The problem is it's not in the path. So I need to go to Anaconda installation. There is one. Oh boy. Anaconda. There is one, you see that Anaconda prompt. If you cannot run it in the command prompt, means that the environmental variables are not defined.
Okay.
Maybe I didn't set that because I use other environments like PyCharm. I didn't want this one occupies the path when I type.
Oh, gotcha. I gotcha.
Yeah. So long ago, I need to reinstall everything anyway.
Oh my gosh, me all that. I need to reboot like desperately, but I can. I have like, how am I gonna remember my 20 tabs that I have open and my 50 emails?
Yeah. So this is, it doesn't need. So if I say Jupyter, sorry, notebook, then ta-da. It does the same thing, right? But the difference is now I'm inside the test folder
Okay.
that you see here.
I know this folder.
Yeah, so
I know this
yeah,
cats and dogs.
yeah, exactly. So this is where I can just create a new thing, and I'm gonna say new Python, right?
Do you want me to be doing any of this, or I'm just watching?
Well, at the moment, yes,
Okay.
because this is introduction, so
Yeah,
that's
fair.
why. Next week is gonna be hands-on.
Okay,
So
my mouse.
I want you, please, my apologies.
Sure.
Just type the same thing. A equal to this time 1.
Plus 1,
Lovely.
and then what was it?
C.
C equals A plus B, right? Is that what-
Yes. Excellent.
Oh, I forgot my shift. And then I said, I'm just gonna
C,
say C.
just C. Lovely. Bravo.
I gotta get
So-
used to the shift.
So add from today to your resume.
Okay.
So it's type print.
Oh,
Open parentheses,
Okay,
please.
and then the C.
Okay, I've forgotten, or don't tell Pamela that Resume's forgotten this. We use strings. What do we use for strings? Single quote or double quote?
I don't know.
For SQL, use single quotes. For C# use double quote. Here,
Okay.
feel free to use either.
Okay.
So that's why whenever you think that which one, feel free. As long as you're consistent, you say double quote. Please say hello world.
Oh, I see the quote, sorry.
Yeah, sorry. Yeah, just say hello world instead of C.
Oh, actually,
Say
hello world.
yeah, close parentheses,
Okay.
and yeah, and shift enter. Okay, you wrote your hello world, so add that. I'm skillful in Python to your resume.
I'm going to. I
Yay.
need a raise immediately.
Yeah. Awesome. Now we have that thingy. By saying that we finished this one as well, nothing is important here except just, installing Anaconda. I mentioned it there. The next file that is this main kind of things. And by saying that, well, let me just quickly go through this. Different versions of the Python. I remember them. I'm going to ask in the quiz. I'm joking. Just
I want to
Just-
impress you.
But it's not important. It
Yeah.
just shows that how fast we had different versions.
Yeah, yeah. History is important
Yeah.
to understand, to not make the same stupid mistake.
Excellent. Yeah.
Mhm.
And the thing is, here is the place that whenever you want to, in some places, whenever you want to install, for instance, PyCharm, it says that have you ever installed the Python? So you can just have no IDEs and work with the language. I remember the time that I taught ASP.NET Core. In the first session, people generated a website, complete website, without using any IDE, just using a simple text environment.
It's been time consuming and
It was, but I wanted to tell them that, hey, this IDE that you see has nothing to do with the core of compilation. This is just there to ease the job for you. The main part is the engine. And you can just do it with the text. Then I brought them to the Visual Studio Code. Still, they need to install lots of things. And after that, I brought them to Visual Studio. Now, enjoy the facilities that they provided. And now you can appreciate, because you have seen that how hard it is to do all this debugging. So getting back to this one, why Python? I already talked about it. Simple syntax and so on. Again, why Python? Lots of company. So read it, please. Read it aloud.
actually my glasses
Oh,
kind of.
it's in the note as well.
Oh, it's Python Zen. You
Awesome.
got me again.
The thing is that this thingy, if we go where it is here, if we go there, Control V, this is actually one of the things that when I want to work, I listen to. And
This is the type of stuff I like. I don't know if you noticed.
Yeah,
And actually, me and Pierre the other day, he put his music on, and it was lyrics, like it was actual pop music and stuff. I'm like, I can't work to this.
Yeah.
Need.
So this is I very much liked the way that this samurai is in a Zen position. And combining this with what we call Python Zen. And there are some nice musics that I want you to listen to them. It's just funny
Okay.
to put them there. But I'm saying I'm gonna bring everything nicely, neatly in a group that we're going to have.
Okay.
But meanwhile, this is first. Let me just get rid of that because it's not in the order. Delete also for Kelly. That's the first one. That's the second file. I can group them, but it's not.
Oh,
This
just
is the. This is the. These two files are not important. I don't bring them here. I bring them there
Okay.
because, and this is the number 2 file that we already talked about.
Okay.
So you most of the time I have the things in the node part. The whole idea about this Zen
Mhm.
the whole idea about this Zen part is beautiful is better than ugly, simple is better than complex. And even if it says that complex is better than complicated.
What does it mean, or how do I interpret it?
Yeah,
I guess complex, the way that I would look at that is complex just means that something probably has a lot of moving parts and there's a lot to it. Where complicated means something could be simpler, but it's a pain in the ass, I guess, just to be. Like I maybe that's how I would kind of look at that. If you were trying to make that argument, like, yeah, just
excellent.
because something is complex doesn't necessarily mean it's complicated. And something very simple can be complicated if it's not organized or explained properly or whatever.
And that is why I provided simple, complex, and complicated in this diagram. So it shows exactly what
Yeah.
you said. So these are many, many dynamic things, but you cannot, I mean, well, this one is lots of things that you cannot organize them in your brain and
Yeah.
just have it. Flat is better than nested. We're going to talk about that. Python is awesome language that you can just make the thing work like this.
Oh, I love that satisfaction.
Right? And I'm going to show you some examples later that what's the difference. In other languages, you have to go through the loop. Say, first element, take that, multiply it by 2, second, third, fourth. Here you just say, this is the vector, multiply it by 2. It's going to automatically do this. You need no loop for such a thing. So, and it drastically increased the performance. So sparse is better than dense, definitely. So don't put all the codes in, just have a place to breathe and comments and so on. Readability counts. Special cases aren't special enough to break the rules, although practically beats purity. The thing is, just one thing. Most of the time, we follow the regulations. There are cases that we have enough reasons to break the rules.
Of course,
yeah.
the rule's the rule until there's an emergency or until we have new information or whatever it might be, right?
Yeah. And so on. I'm not gonna take it. I know that as a person who is very much tidy, you have it in yourself. In Python, Zen is not that much, but this is Python Zen. If please now open a new tab. And please just type import, Google Colab.
Oh, sorry.
Don't worry.
You want me to go to collab in this
You
time?
just type Colab, and this time it's going to maybe.
Once I keep putting another B, that's why.
Yeah, awesome. New.
Okay.
And just type import this. Yeah.
I'm having import this.
Yeah, and shift enter. And it's going to show you the Zen of Python in a few seconds. Right? And the thing is, so you have it in the slides and you have it there just by saying import this. If you see we have not only this standard, we have other standards. We can use graphic user interface applications, console applications, or DOS kind of environments, web application, scripting languages. What are the scripting languages like HTML, for instance?
Okay. Yeah.
Or okay, so This is the example of console. We
Mhm.
have just seen that you can just run saying that Python.future value dot py, the extension for it. This is the graphic user interface. This is I kind of
Oh, just how you're doing all the same thing, but just a different form of.
just examples, not the same necessarily things. These are just examples that I
Yeah.
can use Python for that. And I think that for today, we covered everything all the way to talk about the execution process of
Okay.
Python. But there's a kind of thing in compilation. We had one architecture, one operating system run everything in here. If I wanted to bring the code from this computer to your computer, which is just a different version of operating system, while it is the same operating system, sometimes I needed to rewrite the whole
Oh my
code,
God, what a nightmare.
right? But what if I could just have something like, hey, I'm gonna say something that is general, but the converter, a translator here is going to take care of bringing that code, which is a kind of general code, to a specific operating system here. And by saying that, just let me give you one example. Imagine that in this computer, the room numbers start from 4033.
Mhm.
In the other computer, they started with 30 something, for
Okay.
example. I say save in the first memory location,
Mhm.
save in the second memory location, and I don't care if you started with 4 or with 3.
Mhm.
That's the responsibility of this part.
Yeah.
This is what made Java what we know.
Mhm.
Being transparent can just shift. You need to have Java virtual machine.
Yeah.
Later, the gentleman who had that idea went to Microsoft, implemented that in C#. That's something that's saying that, hey, who can just say anything on top of what I know?
Yeah.
So kind of like, I mean, yeah, now a new competitor in the market. So
Classic.
C# went there too, yeah. And then they had that idea to have the same architecture here in Python.
Mhm.
So we are going to go a little bit next session,
Okay.
talk to there, and we get our hands dirty.
Okay, cool. Yeah, I'm excited.
So this is pretty much for today.
Thank you.
No worries.
You're a good teacher.
Oh, that's very nice.
Yeah.
Okay. I just would,
I'm sure you've been doing it for a while, so.
well, thank you. I very much enjoy having these kind of knowledge transfer with each other.
Yeah, absolutely.
One of the things that I
Yeah.
enjoy learning from you.
Me too. Well, and honestly, like I said, like I've been doing a lot of the same thing for a long time now, so it's exciting too to kind of have a good mentor this is not only going to help me in, my job here to support you and everybody else and the students, but it's good life development too. And it's good to kind of it's good to get humbled in life too and start from the beginning with something, right? So
It's gonna get super fast
Yeah.
to the level that you're going to say, hey, I know enough, and then we are gonna just plan for the next steps.
Cool.
But I'm happy that the hardest step is always the first step.
Often.